Hi, I'm Bill Hurd. As you may know, I've joined with Fran Blanche to make videos and talk tech and do some other cool things. And what follows is the first time we ever got together, the first show, if you will, from June 14th. Unfortunately, while we were recording, we had an error, and it was a whopper. It turns out one of the cameras was putting audio into the system through HDMI plug, and it was waiting a good 40, 50 milliseconds to do it. So we've got echo, but this isn't your stadium reverb. This is echo like the international long-distance phone calls of the 1970s. So we had a choice to make whether to sit down and shoot the first time again, but the problem is that really wouldn't be the first time. That'd be the second time. And maybe there's something to going forward instead of redoing the past. So with that said, what I'm doing here today is we've doctored the audio a little bit, and we're going to see if it's something that you can enjoy in spite of that echo. Rest assured, we hear it too, but it is what it is at this point. So here we are with some garbling in the background, but this is episode number 1 from the Fran and Bill Show.
Are we rolling now?
Yes, we are,
okay.
And I'm Fran Blanche. I knew I'd blow it. Who are you if I'm Fran Blanche?
I'm Bill Hurd. Well, I'm Fran Blanche.
And I'm Bill Hurd.
And this is the Dinosaur Den.
Well, why is it the Dinosaur Den?
Well, because we're burned out and old and crotchety and antiquated and...
I didn't say crotchety, I said burned out.
I said crotchety.
You said crotchety.
You said burned out.
Right.
I said them both.
Right. I got my hair back!
It's gonna be Geek Girl and Beard Guy. That's someone
posted. That's not gonna work.
Someone posted that on the YouTube comments.
I found that hair is only temporary, so I won't be Beard Guy.
It's much more temporary than you realize.
Yeah.
My hair has been all over. Actually, I'm all melting because of the humidity. I'm all.
Yes, it's. Whenever it gets hot like this, it reminds me of how hot it was when they signed the Declaration of Independence and what it'd be like in the old days.
I remember that day well.
Yeah. Well, see, that works into how long we've been alive, which is why we're dinosaurs.
Yeah, Ben, man. What a character.
Yeah. Oh, Ben? Yeah.
Ben, what a character,
yeah. He proved you could be bald and still get around.
I tell you, Ben, he loved the ladies.
Yeah.
He was very popular with the ladies and gentlemen alike. He would get the men. It's true that we would never, if it weren't for the fact that Benjamin Franklin was getting Frenchmen laid and drunk,
we wouldn't have got support.
We wouldn't have won the war.
Right.
Right. I mean, John Adams was ticked off because he was thinking diplomacy, rhetoric, all that would take place, but here Ben was just getting all the French aristocrats drunk and getting them laid.
He also gave them lightning protection for where they stored the ammunition and the powder. He put up lightning rods and have invented the lightning rod.
The lightning rod and booze. Because we are of the same generation, and
are we?
We are, actually. We're only like 5 years apart.
Oh, okay. I thought we were like 12 or something. Well, I met you. I thought you were, a 23-year-old from Europe or something.
Yeah, I totally have that total vibe about me. Okay. I just scream 20s.
Well, yeah, we met at the Vintage Computer Festival this year.
Yes, BCF East. It was crazy.
Right, and Brian Benchoff? Mm-hmm. How's he pronounce his name?
I do not know, but it is spelled Benchoff, so I've pronounced it as written.
Okay. Yeah, he introduced us.
Did.
Got you filming in my direction.
And you popped into my video about the Commodore.
Right. And Brian's from Hackaday, who I just started working for, and you've been up there a lot, right? You're a contributor.
I'm
a friendly contributor.
I'm a friendly contributor. I haven't actually written for Hackaday, but they've had me on there a lot for my various projects and sundry stuff that I end up doing.
So, well, what's your normal kind of project?
It varies. I don't have a pattern. I just do things I like. So things that catch my interest, which is really kind of what the Dinosaur Den really is going to be about from my end, is just stuff I like. So, in the news, people who watched Colbert this week saw this thing on Soylent. This guy Rob Reinhardt created this universal food that is supposed to be like the chemical, nutritional requirements of every human being. Like, you can live on this food, this liquid food, and nothing else.
Well, what's the fiber content like?
Well,
I mean, when you get to our age, fiber's important.
Well, it's got like fiber, it's got like proteins, it's got amino acids. It's like, there's a lot.
So you don't have to eat the cardboard container to get the fiber.
No, but it does come with like a fish oil canister you add to it, so you can vary the calories, depending on how much oil you put in. But he did it from crowdfunding. It was like $3.5 million he got to do this. So this thing was on, and I was on the Colbert, and I was like, oh, this is like perfect. So next day, I go on the site, the Soylent site, and I'm thinking, I think I'm going to order some of this. And I look at the pricing and everything. It's like, it's not too bad. But I'm like, well, do I want to do a stunt, where I could eat this for a while, or maybe we could both eat it for a while, and do a video on it.
Just you.
Well, no, you might like.
I'll be the control.
Well, this is the thing. I thought, well, it's kind of costly for an experiment. I'll think about it. So I went and I, did some stuff. Came back just a couple hours later. This is like the day after the shot, right? Went on the website. They're totally sold out.
Atkins did the same thing.
Yeah, it's boom. Yeah. So now it's like 12 weeks, to wait for more Soylent. So it totally blew the idea that I was gonna do a segment.
No matter what it tastes like, I'd have to add something to it, right?
Well, no, you
Tabasco
can.
sauce.
Yeah, or whatever you want to add.
Pepper spray. Actually, you can use pepper spray to spice it up a little bit.
You can, but we don't have any Soylent. So, but it's like the geek food of the future, and I'm super psyched to try it. So, if anybody's watching who's got a year supply of Soylent, if you went totally nuts and bought a year, you've got a skid of Soylent in your lab that you're living on it, send us a couple weeks of Soylent and we'll give it a try. At least I'll give it a try. I'm dying to try it.
Now, any copyright problems with the movie Soylent Green?
I'm sure, because it's
made for
people. It's for people. It's for people.
They blew it up. Damn you.
Damn you all to hell.
I love when Homer Simpson does that. Gets on the ground, starts pounding.
But Soylent is, they bypassed the on the website. They bypassed reference to the movie, and they go right to the book. Make room,
Oh, to the book.
To the book, yeah. They're just cutting right to the chase to say, oh, it's about the book. So, but anyway,
that makes sense actually.
But if you go to the description,
they could sue the movie makers then and say, well, actually, we're closer upstream.
They probably got permission for from the book and not the movie. But we have all kinds of information. Like if you want to send us Soylent or any kind of stuff, you can go to the website. It's franandbill.com, which is right here. And also in the description and on the website, we've got mail-in address that you can send us stuff, and you can also give us your feedback by emailing us at feedback@franandbill.com. Anything to do with the show or not, give us your rant, story ideas, tech ideas.
We'll give you our credit card number if you need to buy any of the things or need to charge us.
We will not do that, but
well, I won't be eating Soylent then.
Well, but if you want to send stuff in for us to chew on, I'm going to be talking about theta later, or phi. I think I have phi because we're one of the segments.
We always say phi. Phi 2 like a clock in a processor.
Phi, phi, pho.
Never thought of it that way.
You say phi, I say phi. I say solder, you say solder.
No, I say solder.
I say solder too, but there have been people who have picked me about my pronunciations, my Pennsylvania Dutch.
I don't hear much Pennsylvania Dutch.
Well, it's more of a Philly accent now.
Yeah,
it's kind of by way of Brooklyn, but at my
out in the light.
Yeah, it's talk about getting ring blown at the Wawa. It'll come out every now and then.
It's not Wawa there. It's Turkey Hill, right? Isn't that the local?
Yeah, it's true that the Wawa is much more Philly.
Yeah.
But anyway, I digress. So
We both digress.
both digress. But yeah,
So you're willing to be a chemical incubator for an untested concoction?
it's somewhat tested. It's been beta tested, although
See, you used a Greek letter again.
yeah, it's true, but they called it beta. I think it was called Soylent 1.0, which was the version.
But we all know 1.0 is always buggy.
Yeah.
I mean, does that mean it arrives?
Yes.
It's
Actually, it was really buggy because Vice magazine did a thing last year. It was back late in 2013. They went to this the plant where they were making Soylent. This is like their startup, because they got their crowdfunding, and they were making Soylent in a factory that was sort of much more of a place to make like transmissions than make food.
Yes.
And so the conditions,
Incubate.
yes, they had written about the conditions were less than desirable for like a human food. If you're sitting on a lot of like beta release Soylent, it might have other
Mushy.
things in it. Yeah, I'm told that it's like much better now. They're like in a proper facility, but.
Yeah, I never, well, it's just something in the Japanese language. The word for bug is mushi. And when you answer a phone, you say mushi mushi.
Mushy mushy.
Yeah, so I used to say bugs, and they would, and, they'd laugh every time, so I kept doing it. And it's like, that's because they're polite by training. And we asked one time, I said, well, us Americans must be horribly rude compared to you. They said, no, actually, when you're nice, you mean it. Whereas we will always act nice. And so I was like, wow, okay. And then I started back to acting rude.
Domo.
Domo arigato, because I must stop.
Mushi mushi. That's all the Japanese I know. Origato and mushi mushi.
And so he got introduced to New York.
But welcome to New York anyway.
Yeah. Well, I always had problem with customs in New York. Have you ever traveled with computer equipment and stuff?
In New York.
Well, I'd be coming in. That's where we'd land
flying
on a polar
in.
route.
I've never flown internationally. So
okay.
Yeah.
So
they won't let me out of the country. So
Well, back when I worked for Commodore in the 1980s, if you were going to the Japanese office, you'd be a mule. They'd load you up, and so you had to learn how to survive the trip. Like, they would put those plastic bands on boxes for you that cut the circulation and eventually cut your fingers off. Look at this, lost a finger. So you learn to like get duct tape and a towel and make handles out of them and everything. And then on the boxes they're going to open in customs, you put another roll of tape and everything you need in the box, and when it's opened you can seal the box. But then one time in customs, New Yorker guy again, he's like, I have to see what 50,000 keycaps look like, because they're 0.01 cent each, and it was keycaps for the computer. He opens them, they go everywhere. And I just looked at him and said, you now own 50,000 keycaps. And I walk off. He's like, hey, you can't leave. Not mine anymore. And I left him. We had to call the broker to go back and get him. But the way I looked at it, because I didn't put a roll of tape in that when he tore the box completely open. Keycaps everywhere.
But you did get them back. You did get them
I don't know.
Oh,
yeah, well, I'm sure we got some back.
It's a mystery.
Yes.
It's one of those Commodore mysteries.
Well, helped my reputation for don't load me up too much with.
Well, your reputation is quite solid. So.
Like my hair, right?
Well, one of the things, the space thing. All right, the space news. Well, SpaceX, they.
Here's one.
Yeah. SpaceX introduced their new Super Draco engines, which are the first 3D printed rocket motors, and they're.
Are they printed with PVA or ABS?
It says that the direct metal laser sintering (DMLS), which it's basically just welded. It's basically
It's probably ABS.
Well, apparently it's like
it's cheaper.
It's made of it's a nickel chromium alloy, and so I guess it's a powder that then they use a laser to sort of melt it.
Oh, that's cool.
In layers. But the advantage is that the entire motor is built out of one piece, so there's nothing to there's no moving
stress points and
no
stuff
moving
too.
parts, because they're hypergolic motors, so there are no pumps, there's no moving parts, it's hydrazine.
Now, are you saying hyperbolic or
hypergolic?
Golic. Okay.
So it's hydrazine based fuel. It's hydrazine and and some kind of nitrogen
Now,
tetroxide.
hydrazine's like what's on what the moons of Jupiter and Saturn. Their atmosphere or their water is really hydrazine.
I don't think it's made of hydrazine, but it's there's a lot.
The same kind of compounds in there.
Yeah, hydrazine is an.
The moons would blow up if there was oxygen to support oxidation.
It's one of I might be wrong, but I think it's one of the most toxic substances around is hydrazine. I know people used to get. I mean, you can't be exposed to any of it like in any concentration. It will destroy your tissue.
Now, does Soylent have hydrazine in it?
I don't know. The beta version might might have.
Are the bugs alive or dead?
Well, we can only find out by trying it ourselves.
Nope. Been there, done that.
So,
Yes, sorry, get back to you.
No, but these 3D printed engines are pretty amazing because it's. I've been really waiting for like practical applications with 3D printing technology, and this really seems to be it. Complex machines that won't have to be assembled or welded from parts. They can just be made in one piece. So these 12,000 pound thrust engines are just and they're reusable too. They're not going to be disposable. They're supposed to be reusable.
Oh, so not even as raw materials, but reused as
reusable,
as assembled.
So the new Dragon spacecraft they unveil with these new Super Draco engines, everything is totally reusable. The idea being that these things can be flown and then landed with rocket power, and then just refueled and flown again.
So you need to land on a place that's got rocket fuel.
Right, you have to land in a country that's got rocket fuel.
Okay. Well, I think I've heard that like traveling to Mars, 3D printers will be an integral part of survival on that, as far as like making parts to either replace stuff or to make things as needed rather than carry everything.
You'll have to 3D print your engines to get back, probably.
Yeah, out of rocks.
But can you 3D print your fuel? That's the question. Getting to Mars.
Ice sculpture. Hydrazine sculpture.
Yeah. Well, I don't think we'll be going to Mars for in my lifetime.
No.
I don't think the money's going to be there. I think there'll always be more war to throw our money at than science. I think that's the problem.
I agree.
With
Yeah. Yeah. And it took a commitment. Everybody right now is talking about how to save our way into prosperity again, and that just doesn't work. And some of the proof that we're from the age when one day we had not walked on the moon, and the next day we had.
Right.
Most people believe that. I mean, there's still a few hang-ups.
You don't have to believe it that you can see the landing sites from orbit.
Yeah.
And
that laser, the retroreflective mirror.
Exactly. Yep. Yeah, you can fire a high-powered laser from Earth.
I think you get back like 4 photons, something like that. I mean, they're definite, but it's only 4 to 7 photons or something.
There are observatories you go to where they still do fire the laser at the reflector. And apparently it's still reflective, so it's not covered in dust yet.
A little curve, yeah.
So, but yeah, it's all there. I mean, the Lunar Reconnaissance Orbiter, which I had published on my blog last year, they have released photographs of all the Apollo landing sites and all the Soviet Luna landing sites too. And you can,
including the crashes, right? They had some unmanned crash.
Don't know if they have. Well, you'll have to look at the Reconnaissance Orbiter website. I don't know if they have like crash sites, but they do have all the landing sites.
Okay. Landing. Crashing's landing.
It's landing very fast.
Yeah. So, Hackaday. We all know Hackaday, right? They are giving away see how small that is? A trip to space.
Now, what does that mean? A trip to space? I mean, are they going to strap you to like a firecracker? And
I assume it means that you can brag you went to space.
I mean, are they going to give you a helmet? Do you get to...
I assume they're going to let you brag that you went to space.
Yeah, but how are we going to get to space? I mean, how are they going to do it? What do you...
I don't know the details of that, but I think it's like the Branson type thing. Virgin Airlines goes higher, bring your own peanuts, that kind of thing.
Is Richard Branson aware that someone is going to go to space via Hackaday?
I don't know.
I guess we need to check up on that.
Call Richie, yeah.
So if Richard Branson is watching, maybe he can let us know how they're going to get us into space. Oh, yeah. So this is the Dinosaur Den. What is it for this week? And it's a vintage galvanometer. more specifically a mirror galvanometer, and I picked this up at a thrift shop, not knowing if it worked or not. Turns out it does, and so, you know, I really don't have any idea of how old this is, but it's made by the Rubicon Company in Philadelphia, question mark on the year. But galvanometers like this were used as they were really the first precision instruments for measuring voltages and currents, very small voltages and very small currents, by use of an internal mirror. So it kind of might be kind of obscure looking at because it's just this wooden box, which actually, can we get a close-up of that with the oh, look at that technology. So here I've got a 6-volt lantern battery hooked up because the internal bulb in this takes 6 volts, so I'm using the lantern battery. And you can see the little indicator there, that little orange circle. And it's got this frosted glass scale, which is adjustable 2 ways. It's got this coarse adjust on the top, which adjusts the mirror, which I'll show in a moment. And this fine adjust here, which this little fine adjust, what it actually does is the scale, that little glass scale, is actually, it's like a glass slide, and it's in rails, and it's got a spring pushing it this way, so the fine tune, all it does is actually moves the scale left and right a little bit, and you can zero out the mirror. But that little orange circle, there's a fine vertical line, which we'll get a close-up of this later, but when I open it up. But really what it is it's basically like a panometer. It's cut back to the wide shot. So, where's that panometer we had lying around? I know, right? Okay. So yeah, so this is the panometer. This is your typical panometer. It's, you know, it's got stationary magnets and a coil of wire and a needle, and it's balanced on springs. And you put a little current through it, and the needle will deflect. And this is basically the same thing, only with a much narrower movement. So if you imagine a panometer like this might have 90 degrees, 100 degrees of swing, something like that. But the mirror galvanometer is basically exactly the same thing, except instead of reading a needle, it's got a mirror mounted on a shaft that's inside of a stationary magnet that's got the coil on it. So instead of moving a needle, it's actually moving a mirror, and there's a beam of light shooting at the mirror on one angle, and then the reflected beam is broadcast onto this plate here. The idea being that the throw between the mirror and the scale is actually quite long, so you're actually looking at a very minute motion in the indicator, so we can actually measure very, very, very small voltages. So Alright. So, now we got the top off, I'm going to switch to the other camera. Okay, so this is inside the galvanometer, and this is the frosted glass plate, a little slide, glass slide, and there's the counter spring pushing against it. And down in here, this is the beam. It's just a little box with a lens. Actually, I don't know if there's even a lens in there. It's just like 2 apertures. They're separated in a tube. So it's basically makes a narrow beam just because the bulb and the reflector
laminates it, or whatever.
There's 2 apertures. There's like a small aperture and then another aperture, so it makes just a directed beam. And that beam is going through a hole in the back plate here to a mirror that is on top of a coil of wire, which I'm going to get a close-up shot of that. Fortunately, this won't actually go
Did
down.
you do that solder? Because that does look like something done after the original.
No, this is all original the way it was, but I think this was redone.
I'm agreeing with that, because that solder is newer than 40 years old.
Yeah, well, you can see down here. This this might be newer. I mean, because that.
Yeah, the melt mark on the makes it look kind of newer to me too.
Yeah, this might be reproduction.
Look at the cut in the wood. It's a little rough. You'd expect the cut to be kind of smoothed down, you know, if somebody hand built the wood case.
Well, this is anodized, so it can't be that old. You know,
It's not just anodized; it's hard anodized.
yeah. So this all looks new to me.
Yeah.
It might be a reproduction.
Yeah.
Okay, so with the macro lens, let's see here. All right, this is inside this is the mirror part of the mirror galvanometer. This up here. Alright, so this up here, that's the coarse adjust for the zeroing it out, and that tab up there, that conductor, that is hooked to the top end of a very fine metal cable, which is suspending the coil mechanism down there. It's inside of that stationary magnet. So that cable, there's a cable on the top, you can see it right there, just barely. See right there, cable right there. And there's a cable on the bottom, which are the two ends of the coil. So there's one conductor on the top and the other conductor goes to the bottom. And so on the front side of that coil is, right down there, that coil is a mirror that reflects the beam that's going through that little opening right there. You can see in the reflection in the mirror there of the beam.
Is the mirror front reflective or rear reflective?
These are all front reflective mirrors. Yeah, there's 3 of them in there, and this one on this side is used twice, and the back 2 mirrors are 2 different angles. So it actually goes from the projector through the slot to the mirror on the galvanometer meter, to this front mirror, and then to that mirror, then back, then to that mirror, and then to the scale in the front. So, alright, so on my photo stand, here's a drawing I made of the galvanometer. And this is a side view. This is the light source here with the lens. This is the coil with the mirror on it, and again, it's suspended inside of the galvanometer with this wire. It's very taut steel wire that allows the coil to sort of twist and rotate inside of this stationary magnet. And you've got one pole of the coil on the bottom and one on the top, and there's also the fine adjust there that allows you to adjust where the center of the mirror is just by adjusting where the center of the torque of that wire is. So it's just the torsion of the wire is what the coil is actually just twisting the wire a little bit, and then it'll center, and that's the center control there to get the center here on the little indicator screen, which is up here. So this is the side. There are 3 internal surface reflecting mirrors. There's 1 in the front here, 2 in the back, and you can see this pathway. And the reason there are all these mirrors is that the galvanometer is actually taking this very long throw of light and making it into a little compact space that can be portable, so that the box doesn't have to be super big. And this is where this is the little mirror here on the coil, and the distance from that point to the display is actually 28 and 5/8 inches, or 28.65 inches of distance from here to here. So you can see why these mirrors and this complicated light path for this beam is there, because the distance between the mirror and the dial, even though the dial is only 4 inches wide from 0 to 0, the 4-inch scale is just 4 inches on that screen. So having these mirrors allows it to be really compact. But exactly how delicate is this motion that's being displayed up here on the display? Well, do that when you do a little bit of trigonometry. So, alright, so a little trigonometry. Taking into consideration that the whole scale is going to be 4 inches, and that the mirror is, it's stretching out, let's say it didn't have the mirrors inside, that the the mirror on the coil would be way out here, 28.625 inches away, and we can calculate the angle. If we divide this into a right triangle, we can calculate the angle of 1/2 of the scale using some simple trigonometry. The calculation for this is done. Let's just call that phi. So say that phi is equal to the arctangent of, let's call this B, and call the long side A. It's going to be the arctangent of B divided by A, which, get out the trusty calculator here, Texas Instruments calculator. So looking at, so that's going to be 2 inches divided by 28.625, and take the arctan of that, which is going to be, let's see here, 2 divided by 28.625, take the inverse of the tangent, so it's approximately 3.9 degrees, which is pretty impressive. So the entire length, or the entire length of scale here, is only about approximately 8 degrees of rotation on the coil. So your typical panel meter, analog panel meter, the same kind of mechanism, you've got a little coil in there and little stationary magnets right in there. They're internal, and you've got a little needle. The range for a typical panel meter from point to point, the maximum deflection is anywhere from like 90 to 100 degrees typically. Usually it's no more than that. So the galvanometer, being basically the same kind of analog meter, it's deflecting only about 8 degrees, or about 8% of a typical panel meter. So the entire range of scale, the reason this is so sensitive, the entire range of scale here for the galvanometer is just a tiny little fraction, just 8% of what you'd have in a typical panel meter. So that's how we are able to get these very detailed readings with a completely unamplified electronic signal, tiny little electrical current, without any amplifiers, transistors, or valves at all. So there you go. The half scale here is 2 inches, so just using trigonometry as I showed in the diagram, the total amount of angular motion is just 4 degrees from 0 to 5, so that's 4 degrees, which compared to the panel meter, this panel meter is about 100 degrees of deflection, so be 4% of the motion on this would be for half of this range. So let's say 8%, so 8% of deflection on this would be the full scale. So that's pretty amazing. All right, so we wanted to try and actually power this thing up, and when I got this, I had no idea if it worked, but it actually does work, as we saw with the light coming on. But we really had no idea of what the scale of this was, or how sensitive it was, or even what it measured. So
so I went and got a lemon.
A lemon.
So yeah, I mean, it came down to, one, we didn't want to damage anything, and I don't have a precision current source, and I've made a note. We're going to learn some FETs and make a precision current source to have around next time. But also, I kept hearing this word galvanometer and galv, and so I'm like, well, galvanic, 2 different metals. So I went and I grabbed a zinc-plated nail and a piece of copper. And then we had a little contest to see what the voltage would be. So we did. How many volts do you guys think what you get out of a piece of copper and a piece of zinc? So what we're doing is now we're just going to hook it up and we're going to get a deflection on it. And the only thing we've done is I've put a series resistor in here so that the voltage drop across here can vary based on current, not just the voltage output. So I'm giving it a dropping source. And that means this goes here. And what'd your deflection do?
I don't know, put it on the other camera where we can see the...
I should probably have had it there before I put it on.
It's bouncing a little bit.
So let's let her stop bouncing and we'll go into it again.
Yeah, it's bouncing a little bit. This is very sensitive because the mirror is actually suspended by that taut wire, so it only centers itself based on the torsion of the wire. So it does tend to bounce. We were trying to do this before when we kept bumping the box and knocking it around. So.
Yeah, when I worked at a scale company in the late 70s, we had these very sensitive 2-pound scales and in the R&D lab, and we noticed every day after 2 o'clock they'd start jumping. Just every now and then they'd jump. And we're sitting there, we're thinking it's the power supply or their turns, and we realized there's a press all the way on the other side of the building. They would only run it after lunch, and it was hitting the concrete floor enough to vibrate our thing all the way on the other side of the table. And it was just a press punch. So that's how we troubleshot. It's so sensitive, the press punch hundreds of feet away in a factory.
Okay, so...
Get the,
Sure,
do you want to put the lid back on?
Yeah, that's probably what we're going to do here. It's shiny. I think this whole thing is reproduction.
Sometimes I look and it doesn't look like solid wood, and other times it does. It
is solid, but it's just...
It's weird.
It's almost like it's like a very accurate reproduction of like a turn of the century instrument. It might be a reproduction, but I don't know anything about this Rubicon company, so it's just a mystery.
Well, I know what the Rubicon River is.
Yeah. So it seems zeroed. That's the fine adjust there, moving the scale, but it looks like it's kind of gotta look head on. Okay, so it's zeroed. Okay, so we can see the beam there, and there's actually a fine line which is barely perceptible. It's actually in the center, so I've got that zeroed. And so Bill's going to put on
the lemon battery.
Lemon battery. Oh.
Lemon current source. Voltage source.
Oh.
A source of nutrition.
It's going off scale. Okay, so now here's the part where we have to wait patiently for it to stop bouncing. And it's deflected there because the coil has turned the mirror slightly because of the current going through the resistor that we have, which is what, is it 20K or 22K?
22K, which we didn't get right the first time. We changed resistors till we got a nice full scale out of it.
So we got 22K at about, I think we were reading at the lemon at like 0.97 volts or such. So it should be somewhere around 100 milliamps. Ooh, and it's stopping right about at the top of the scale there, which on the DMM we have is reading
0.122 volts.
Okay, so there we go.
Well, now you got me curious.
Okay, so got the calculator out here.
Okay, so being that I can't do anything without a calculator because I'm an engineer, what we did is we took the voltage of the lemon as we measured it, which was 0.122. Remember, we've got a resistor in series to let the voltage go somewhere else if it needs to. And we divide by the 22 and we get 5.5 microamps.
Which, if we switch the camera to the scale, it's showing it's up at 5 plus, so the 0 to 5 on the scale is microamps.
Right? And I thought this would be milliamps, and you were right about microamps.
Well, I thought it was going to be a very small, because as we calculated the actual throw there, for if it were actual meter, would be like 4 degrees. That's like 4 degrees of swing on the actual meter itself. Right. So you can imagine a panel meter where you're trying to read 4 degrees, which is probably like it's 32nd of an inch. That would be the entire length of this scale on a regular meter. And the really cool thing about this galvanometer is that there's absolutely no real electronics in it. These meters were designed before amplifiers, before there were valves, before the triode. And so it's amplified. All the amplifications done here is done with optics. It's using optics to magnify the motion of the meter so that you can read this very, very small scale. And it turns out it's actually pretty damn accurate.
Yeah. The other surprise we had today was if you guessed how much voltage comes out of a lemon. What'd you guess?
I thought less than a volt. I thought maybe a volt somewhere less than a volt.
You said like a point
I think I said
0.2.
I said 0.1, 0.2 volts. I'd be pretty happy with that.
And I was at about 0.8. I figured silver would do. But it turns out 0.9 volt. Actually, it was closer to a volt. I think we're wearing the lemon down.
Yeah.
But when we first hooked this up, we got a volt with cadmium on one electrode and copper on the other.
Yeah.
So
it's actually kind of a viable power source, a lemon.
And it goes good as a garnish or on a salad. Yeah.
There's the pulp factor weighs in with efficiency,
Right,
because we found out as we kept poking it more and more with the nail, we got less and less voltage each time we poked
Plus,
it. So,
I got lemon juice in the eye. And you don't want that.
So.
All right.
Wow.
Well, you were going to ask everybody if they can.
Yeah, because this is made by the Rubicon company. Like I said, we've been actually sitting here trying to figure out how old this particular galvanometer is, and it's kind of a mystery box because it looks really old. It's sort of handmade. Some parts in there look like they're PVC. Other parts look like they're like turn of the century. But if anyone has any information on these Rubicon, whether they're, I'm assuming it's a reproduction.
Yeah, I saw 3D printed parts in there. Yeah,
there are no 3D printed parts, but there's some anodized parts in there.
Yep.
So it's definitely 20th century. But anyway,
it's got wood grain wallpaper on it.
Yeah, so it's all fancy.
It's solid wood.
So anyway, the mirror galvanometer. Who knew? I highly recommend picking one up. They're semi-portable, meaning they weigh less than 100 pounds. They hardly...
the IBM standard for portable was 70 pounds, if I remember right.
I mean, they're fast because they zero in under 10 minutes. And, yeah.
And a quick search of the web showed that the first time they read like brain waves and stuff, neural, they did it with this stuff. This was the first accurate, or sensitive, I should say.
And this actually make a very good seismometer too, because just right. Even us moving around is moving the meter. You really have to have this on a really, really sturdy table.
And lemon tester.
Lemon tester. Well, that's sort of an external option, I would think, more than.
So and final question: if we used an orange, what would be the voltage? And see if you understood the mechanism at work.
Yeah, we're short on citrus today, but
it's like that old Gilligan's Island episode where Gilligan didn't know that lemons and oranges were the same. Then he had that dream.
Yeah, it's like the episode where he made television out of coconuts.
Yeah, cars. As a kid, I go, well, they have motor cars. Look at that, not realizing that a pedaled car is the same as a diesel-powered golf cart.
Well, the professor can make it happen.
Yeah.
Cool.
Well, that's where I got the idea. Remember one time they powered the radio by stirring little stuff in coconuts, and they had some like little metal things.
Yeah. But he couldn't fix it like a 1 foot hole in a boat.
Well, no.
So,
all right, very cool.
Success. That was cool. I learned a lot.
So one last thing we wanted to pull out today. This is just something I was walking by a few minutes ago and said, hey, let's show you the passage of time. And if you saw a wafer these days in a at a chip fab, they're this size. They're like dinner plates, frisbees. 4.5. That's what we had back then. This is from the old MOS technology back in the 80s when I worked at Commodore. And what's kind of interesting here, one, we used to try and break these. I had a piece of wood. There we are. First off, when you sail them, they fly like a frisbee and then they break like glass. So it's pretty cool. You see people knocking it out of their hair and everything. But I would see people with these things and they'd have them cleaved into 4 or cleaved into 5 pieces, and it was based on which kind of silicon, how the silicon crystal, which one they had. But I never could do it. I would take this, and there's a way to tell the alignment of the silicon. If you see, there's a flat edge there. So that is the alignment of the silicon. So I was making that parallel to the desk and thwacking it, and I'd get glass all in my hair and stuff. I went through 12 of these things, right? So finally I learned that the way you cleave a wafer is you take a pencil point right in the center and hit it, and it'll break into that 4 nice pieces. But this is an old ROM array from the 70s, and again, 4.5 inches. Think about that. You have to do all the expense of running a wafer, but you'd only have a couple hundred die to choose from, or if it's a processor, you might only have 60 or 50 to choose from. And of those, only 10 might be good. So, oh, yeah, here we go. Talk about, here's what a cleaved piece looks like, just to prove you can do it. So, matter of fact, can you see the little computer part there?
So, will that break into quarters if you just push the center?
That'll shatter if you do it again.
But if you push just the center, it'll actually split into.
That's how these were done. Is somebody, matter of fact, see the divot right there?
Are they scribed ahead of time? Or?
No, it's the crystal.
The actual crystal
and structure, right?
Huh.
And so, like I said, I had a chip guy had to tell me, well, you better hope they know the physics of it going on. So, and again, these make great frisbees, but I'm down to my last one, so I won't be throwing this anytime soon. So you're safe.
Yeah.
So
that's cool.
Well, I had fun today. Do you have fun?
Always fun. Yeah. The cool thing is I'm always learning a lot.
We're too short that way, don't we?
Yeah, we don't quite have this nailed down quite yet.
Oh, it's our first show.
Yeah, this is growing pains. You know, we'll look back at this first episode. It'll be
funny.
They'll be playing it at the parties and stuff. You know, it'll be the gag reel is the first episode of the Dinosaur Den. But no, it's really cool.
Yeah, we didn't even know what to call it till we just said Dinosaur Den.
Yeah, well, it seemed appropriate. You know, we're always lamenting about the old days and the old ways, and one of the things that I always found in my blog with getting feedback from people when I would do blogs about old things is that especially younger people were surprised that this stuff even existed, and you know, it's not really
Did
taught.
you have electrons back then?
Well, yeah, I mean, they did different things. Those electrons did different things, but you know, there were. But the older ways of doing things, which aren't really taught today or not really used today, were just as interesting and cool. And I think that a lot of the older technology is just as relevant and usable. Like the galvanometer, I mean, who knew that something like that would be that accurate?
Right.
We're measuring microamps. So.
And we're from the day when you didn't have a computer in the house. There was no computer until then. You could see IMSI in the magazine, and then suddenly you got the Radio Shacks and the Commodores and the Apples came out. But when I grew up, there wasn't. The piece of technology was your TV set, and because it was tubes, it was user serviceable. So first thing I learned from was my TV, and I thank goodness I learned without ever hitting the high voltage.
Yeah, the first computer I had was the C64. I got it in the summer of '93. Got 83, summer of 80,
oh, okay.
83. Yeah,
that'd be an old 64.
Yeah, an old 64. Well, I was still using it in the 90s, actually. I'm still using it today, actually.
Yeah. Well, I get asked, do you use a Commodore 128? My answer is, if I really needed one, I would just simulate it on my 3 gigahertz Pentium, you know. Because back then, the fastest computer had an 8 nanosecond cycle time. That was the Cray XMP. And we were like, oh, 8 mils, you know, and now you've got one at home. So you live in an exciting time. And we're here to remind you of that.
Yeah, we live in an age of supercomputers and operating systems that are so big they just bog them right down to the level they were 10 years ago.
Right. Yeah, and I don't really lament all you youngsters. I lament the body parts falling off. That's
yeah, well, as you get older, you kind of get whittled down.
Yeah.
We were talking about this. You know, there's sort of less of you every year to talk about. So.
All right. So you know, send us your feedback. Right?
Yeah.
Do we want feedback?
Yeah, we definitely want feedback. You just email feedback at franandbill.com.
How do you spell that?
Fran-n-bill 1l.com. There's a link in the description, and I'll put it up on the screen too.
So well, don't type the word dash.
Yeah. It's not. You don't type the word dash. It's just a hyphen.
Remember ampersands? What do they call them now?
I think they're still ampersands, actually.
But periods and dots.
Well, but you know, a pound sign is now a hashtag.
Hash.
That's now a hashtag. But I think an ampersand is still an ampersand.
All right. Well, hopefully we'll do this again if the bill collectors don't catch up with us before then.
Yeah, we'll try to keep the power on and try to keep the air conditioning on for next week.
Oh yeah, nice humid New Jersey day here. So thank you for joining us, and
yeah, we'll see you in number 2 of the Dinosaur Den.
bye.
Bye.